Hello, everybody. Be very much welcome. We're just waiting a few seconds so people can finish trickle in. Hang tight on your seats. We're going to go on a deep, geeky adventure into the world of GHG accounting for flavor and fragrance ingredients. Uh, so Again, for those who just joined, be very much welcome to this session on GHG accounting for complex products measuring the unmeasurable. My name is João Brich. I'm Director of Growth and Innovation at HowGood. And today I'm really excited because you are going to get to hear from some of the people who I've personally have learned the most in my own sustainability journey. Jonathan Warr, as Senior Vice President of Research and Development at Takasago, customer of HowGood and flavor and fragrance company from Japan. You're going to hear from JD Capuano, our head of research, and also Gabby Cuevas Castillo, who's our in-house LCA PhD, who's been tackling the complexity of GHG accounting for flavor and fragrance ingredients here at HowGood. If you're just joining, feel free to introduce you in the chat. And also feel free to drop questions as we go, because we want to make sure this is interactive as we possibly can. Now, before we kind of start with the formal agenda, I want to just share with you a little bit of who are the people that we have here on the room. Jonathan Warr is a mastermind. He holds a PhD in chemistry. He started his career at Unilever in the R&D team a little bit more than 20 years ago. He joined Takasago to basically establish the Takasago's European research and development team. Then John went on to founding the company sustainability team. But Jonathan's impact goes well beyond Takasago. Jonathan also serves as the chair of the International Fragrance Association Sustainability Committee and is regularly contributing to scientific journals and patents. So I'm super, super excited that you're going to get to hear from Jonathan today and also from JD. JD is our head of research here at HowGood. He's been leading for many years now the design of HowGood sustainability metrics and the development of the automation approaches to calculate those metrics at scale for very difficult ingredients like the ones you're going to see today. JD, has been working with sustainability consulting for Fortune 200 companies for a few decades now, and has been teaching sustainability and data analytics at Warr College, and has a master's in sustainability management from Columbia. So with that said, that we've now introduced our superstars. In terms of agenda, I'm going to kick us off, just kind of setting the stage about why the footprint of flavors and fragrances matters, and also why it is often overlooked. We then are going to hear from Jonathan on his approach and Takasago's approach and Takasago's journey in thinking and improving the sustainability impact of flavor and fragrance ingredients. And then we're going to hand over to JD Capuano to talk about how HowGood has been working closely with Takasago to footprint these ingredients in environments of so much complexity. If you didn't hear in the beginning, I'll tell you this. This is going to be a very deep, geeky adventure into the world of footprinting the impossible. So hang in tight and let's start. So one of the things, in my work here at HowGood, I have the pleasure of, spending most of my weeks and spending most of my days talking to the sustainability teams at, some of the largest CPG companies worldwide. And one of the things that often comes across is this idea that because flavors and fragrances often have a low inclusion percentage, particularly flavors, that they can be disregarded from footprint calculations, and we cannot focus too much on those and really focus only on the ones that have the highest inclusion. Now, throughout the work we've been doing, for the last years with both Takasago and other companies, we started to realize that actually these flavors, these ingredients for these flavor and fragrance ingredients actually hold a lot of complexity. They hold multiple ingredients, often heavily processed, and actually they can be much more carbon intensive than we might think they are. So I'm going to just show you an example to kind of, prove and demonstrate, a real example of, what this could look like. And if you think of, a chocolate wafer product that has sugar, flour, milk powder, fats, cocoa paste, cocoa butter, and all of the ingredients that you see here, each of these ingredients has a specific weight. And on the right-hand side, you can see the land use change emissions factor of these. Now you can see that the flavor system, even though it's just 0.2% of the inclusion of the product, it actually has the highest land use change emissions factor. And if you double click here, you can actually see that, why is that? You will see that, this flavor system, is basically built upon a carrier and then has a sequence of flavor ingredients that are, mostly natural extracts in this case, that in some cases can have really, really, really very intensive carbon footprints. Now, I'll show you this in a little bit more detail. So if we actually go into kind of, see these live in the platform, so you can also kind of relate to this in a more, more specific way. This is the chocolate wafer that you were just seeing. This is the carbon life cycle of the wafer. And this is the formula we were just seeing, right? So you can see here that there is the agricultural emissions factor, there's a land use change emissions factor. And you can see over here that actually this flavor system is actually quite carbon intensive. And if I click here to open the composition of the flavor system, it actually, I can see what is driving the footprint of the flavor, of this particular flavor. So let me just show you here very quick while this is showing up. So looking at the flavor system, again, you can see we have the carrier, which is 82% of the inclusion. But then you can see here all of the different ingredients, flavor ingredients that have these very, very, very high percentages and very high carbon intensities. So with this said, both HowGood and Takasago went on a journey to kind of footprint and try to understand, okay, how do we kind of start by measuring the impact of these ingredients? And second, how do we improve them? And so I'm going to pass on to my dear friend, Jonathan, to take us through a little bit of, Takasago's journey and approach to this complex challenge.
Okay, so thank you. It was a very glorious introduction. So I hope I'm not going to disappoint now. I've been built up so much. Anyway, so first of all, probably many of you on the call don't know who Takasago are. It's the biggest Japanese fragrance and flavor company. So as you see on the list, we have 4,000 people. It's 9.2 billion. Unfortunately, they're Japanese yen and not dollars because there's quite a big difference between yen and dollars. But anyway, it's a good number. It's basically $1.6 billion split between fragrances, as you see on the right, aroma ingredients, and flavors. And then we have a small business in fine chemicals and other bits and pieces. So we're supplying many FMCG goods, FMCG companies with their fragrances and flavors because we're not the end market product. We're an ingredient in their products. If you keep going down. And just to get an idea, we are spread around the world. So literally from North to South America to South Africa, up to Europe, going across to Singapore, Australia, and then of course Japan, where our headquarters. We're spreading across the world, which means that we also, of course, have global customers. And typically, it's the biggest global customers who come to you earliest have come to us earliest with their carbon footprint requests. So it tends to be a bit of a trickle-down effect. They come first and then they get followed by everybody else. And the list of questions keeps on getting longer. The only other detail in there, of course, when you get into Southeast Asia, halal becomes a bigger issue in Indonesia and these countries. So you see we have a number of facilities which are halal certified. Keep on going. So the big question, why do we care? And the reason we care I'm sure many of you have seen this diagram before. This is the Stockholm Resiliency Center document, which talks about the planetary boundaries and how we're passing the planetary boundaries, in particular, the climate one, which is the one at midnight. I hope it's not the clock ticking towards midnight, but on the midnight on the hour dial, you see that the climate boundary is the one that is one of these boundaries, which is now very close to getting crossed, and if we're not careful, irreversibly crossed. Is that then an inevitable outcome? The answer would be no, because, for example, if you looked at stratospheric ozone, that was on a very bad trajectory, and then the CFCs came back under control, and stratospheric ozone has now come back to green. So it's not irreversible, but of course it requires action, and if we don't take action, it will become irreversible. So if you then keep on going. Many of you may have heard of this science-based targets. So science-based targets is an organization which kind of validates carbon reduction plans of companies. And we always talk about scope 1 and 2 and scope 3. I suspect most of you know the difference, but just very briefly, scope 1 and 2 is basically within your factory walls. So this is what your burning of fossil fuels, releasing of refrigerant gases, electricity. That's all your scope 1 and 2. Scope 3 is the raw materials. And I've put up here a selection of companies here. And basically what it tells you, if you look at scope 1 and 2, many companies are saying that they're going to get roughly reduced by 50% their carbon footprint between now and 2030. And on scope 3, there's a kind of tendency around the minus 30% is where people are averaging out. Why those numbers? Because they're the numbers which are linked to the 1.5 degree target. That's why people are anchoring around those types of values. So again, some people are more ambitious, some people are less ambitious, but you see a kind of clustering around those numbers. From our point of view, scope 1 and 2 is actually relatively small in terms of fragrance and flavors, scope 1 and scope 3, which is the raw material, all the production and cultivation of naturals, but also manufacturing of synthetic ingredients. Scope 3 is where the heavy lift is. This is where the majority of our footprint is, which is so why we have focused a lot on how do we get better data on scope 3. I would say also scope 1 and 2 tends to be a little bit easier to get around. And I apologize if your company is not up there, but it's just a selection. Zhao already mentioned about the level of inclusion. So flavors indeed, typically the inclusion level is relatively low in the product, even if it can have a significant impact because of the weight that it carries in terms of carbon footprint. The story is a little bit different on the fragrance side, because here we can have products which have got really much higher levels of fragrance inclusion. So for those of you who use eau de toilette or body sprays, some of the more concentrated versions are up at 25%. A body spray would be more than 3%, but you see a very big range. And when you get to air care, so for those of you, particularly in the US, where the market is very big for liquid electric plug-in, those are 100% fragrance products. Candle would be down to maybe just a bit below 10%, but really these are big, heavy levels of fragrance and really contributing very significantly to the footprint of the product. Okay. So all our customers come to us to say, what are you doing about it? How do you reduce your scope 3? And of course, always easier said than done. And to be fair, we can't do it on our own. It has to be done with our customers. The routes here. So number one is the easiest one, which is push the ball down the chain and say, well, it's not my problem, it's your problem. So our customers come to us and say, reduce it. We go to our suppliers and say, why don't you reduce it? And so it kicks down the chain. You can do that to a degree, but it typically only gets you so far. But clearly, everybody's putting pressure on everybody in the food chain to get the carbon footprint lower. The second option that you can look at is compaction. So the example that I put on the screen, I just said 80% of a carrier. So, do we need all these carriers? Do we need all these solvents? Typically, they're more low footprint ingredients, to be fair. But it's not just that. It's also the fact that they've got to be transported. So there's a lot of add-on cost, add-on footprint linked to volume. So definitely compaction, using more impactful materials, reducing solvents is a way to go. And in some studies that we've done, we always see it works. In fact, you always end up, even if you use more intense materials, which have typically higher footprints, overall compaction always wins. A third one, more for, well, for everybody in a way, I guess, but more playing higher, and you'll see why on the fragrance side than the flavor side, is this notion of replacing virgin fossil. So kind of virgin fossil is your is the worst in a way in terms of carbon footprint. If we can replace the virgin fossil with renewable carbon, then we have this biogenic reduction that we can account for and reduce the footprint of the raw material and eventually the product. So that's definitely a way to go. If depending on which sectors you're in, you'll see that well, historically people have only really been thinking about how do we replace a fossil with a renewable like a plant, a palm carbon or a corn carbon or something like that. You've seen more recent ones, moves perhaps using what's called biomass balance, which is more like the energy grid principle, where people put green energy into the grid, and then you can buy a certain ratio of that energy. That's kind of the BMB principle, biomass balance. So there are various ways of doing it. It's actually quite attractive because it uses all of your existing industrial plant to manufacture materials. So I think it's going to be a way for the future. A fourth strategy is, and again, João alluded to that in his example, everything's not equal. Some materials have really got high footprints and some low. So, of course, it's got to taste good, it's got to smell good. So it's not, you can't just take that easy, let's just cross out all the materials with a high footprint and not use them anymore. That doesn't work. But of course, you can be intentional and more intentional and decide to select away from the materials with the highest footprint and move towards ones with lower footprint. And this fifth one, which is a kind of difficult one, and again, there was an example that was just flitted across the screen there, is that land use change can actually be a really significant contribution. So again, maybe we'll talk a little bit about that later, but there are some materials, some naturals with a very high land use, and there it's not always a great solution, but you can always think about, do I move from a country which has got a higher LUC to with a lower LUC? It's one of the options you can think about. So anyway, just some general approaches of how we, and I think these are probably industry-wide approaches to reducing the footprint of your products. So easy, go ahead, calculate your carbon footprint. So as I mentioned earlier on, scope 1 and 2 is relatively straightforward because you have got a meter in your factory, which is recording how many units of electricity you bought. You do know how many liters of fuel came into the hot water boiler and everything else. And helpfully, most countries will also give you reference values for the carbon CO2 equivalent for your energy. So normally, provided you've got good accounting principles, scope 1 and 2 is not so difficult. The issues that we face, just bring you very back to the practicality of it all. Again, it always sounds easy, but in reality, within a factory, you may have different operations. So you might have a mixing operation, you might have a spray drying operation, etc., etc. And at least going back in time, we were less careful, I would say, to isolate how much energy was being used for each process. So again, if you, the better numbers that you want to generate, the more information you need, the more detailed information you need. So again, sounds easy, but actually sometimes it's just a little bit more complicated than it sounds. Scope 3, as I say, this is the big one for us. This is where we really want to get get a good number, because with a good number, then you can try to figure out how to get it down. So commodities, especially the fossil ones, but also some of the commodities on the flavor side, these fillers, typically these are high volume materials, big manufacturers. Many of them are providing data these days. When you move from fossil to renewable, maybe I don't know. I'm going to ask the arbitrator Ava perhaps to do the questions when it's a good time, either in the middle or at the end, as you decide.
We can do at the end. Yeah.
Okay. So when it gets to renewable materials, again, as the volume increases, typically we're getting good numbers, and we can do something like that. The big issue is naturals. So again, if you want sleepless nights, use a lot of naturals, and you'll see why in a minute. So one aspect of naturals is typically, of course, you always have some commodities. You have your orange oil, which is a commodity. There are always one or two. Everybody can quote the exceptions, but the mass of naturals are small volume. Small volume, often actually relatively small volume producers as well. This is a look at our sources. So this is a material coming from one of these countries. So if I look at our natural distribution, we've got 136 coming from Southeast Asia, 55 coming from, does everybody know what the island is out there? Madagascar. You've seen the film, go to the island. Plenty of naturals coming from Madagascar. Sometimes it will be variations on a natural because you can get different types of extract, but Madagascar is incredibly rich in terms of naturals. Then 90 is the bigger Africa, 60 in South America, 15 again. Do you know with these? This is the Caribbean. So again, we got places like Haiti and so on who've got interesting naturals which are of use to us, and still quite a few in Europe, 149. Not so many in North America, actually. So you have your mint oils and stuff like that in North America, but it's actually not a very rich resource of natural extracts used in the fragrance and flavor industry. So, as I mentioned, lots of different sources, often small players, difficult to get good data. On top of that, when you talk about naturals, there are very many, a great variety of extraction processes. So again, this will talk to some, but not to others. But cold pressed is, for example, used for orange, where you literally scrape well, you've all done it at home. You put your fingernail into the side of the orange peel and you get that burst. Well, that's the orange oil that you've got in you. It's just got covered in limonene, which is an allergen, but don't worry about that. It's okay. But that's the cold pressed. Steam distilled is exactly what it says. It's the hot water as you boil your kettle. You boil this through and you can extract the oils from naturals. Exuded, the tree gums. Again, I think you will have seen this where you scratch, you make a cut in the tree and out comes exuded, and then you may have to do something. Solvent extractions. So this is done. If the one which maybe most people would know about is, for example, roses. So there is rose oil, which is steam distilled, but there's also a rose absolute, which is done from, it's again one of the kind of royal materials in our industry, which is done from solvents, and supercritical fluid, CO2 extraction, liquid CO2. So there are all this variety of methods, each with their own specifics. What's their yield, how much land you need, etc., which makes it actually pretty complicated. And those are the easy ones. Because after that, you get to further levels of difficulty, things like biotechnology. And again, people talk about the one or two big high volume products from biotechnology, but there's a long catalog of very small materials from biotechnology and, really very, very limited data. And also this topic of soft chemistry, which may speak to some, not to other, but you can take an isolate of a natural and combine it often with things like acetic acid and stuff like that to make an ester, and they're still naturals. But again, now you get into more and more complex processes, which make it more and more difficult. I hand over.
Joao, you're on mute.
Thank you. I was in awe with Jonathan, and so forgot to put myself off mute. So as everybody saw, I think now we're going to be looking, with JD into kind of what was the approach to kind of, now that we have a pretty good and accurate picture of the magnitude of the challenge, what are some of the approaches that Takasago and HowGood have been taking to address it and find the light in the middle of darkness? So JD, on to you.
Thanks, Joao. And Jonathan is always insightful to, hear from you. So thank you too. How Good, for many of you on this webinar who know How Good, we're dedicated to supporting sustainability in the food industry with our platform designed to accelerate you towards results wherever you are in your sustainability journey. And, some of our customers are getting started with Scope 3 with little data and limited resources and experience measuring impacts, while others are farther along in the Scope 3 journey with extensive data and experience measuring impacts, similar to Takasago with what we've heard from Jonathan. The food industry is being held accountable to very lofty goals, as are other industries like fragrances, especially any of these industries where consumers pay the most attention, and that's in me, on me, and around me, right? Those are the things we pay the most attention to around sustainability, especially with consumer economic choices that they make, where they're more likely to pay for sustainability. And Takasago is right in the middle of that category there, the in me, on me, and around me. And collaborating with Takasago, it was really a natural extension of our work to branch out further into flavors and fragrances. And as Jonathan said, the naturals is where your nightmares begin. And many of the same materials can be used for either fragrances in non-food consumer goods or aromas in food products. So, it's very interesting overlap for us, both from a business perspective and then intellectually for my team that has several members, including Gabby, that are deeply interested in the topic but previously restricted based on limited publicly available data. And the purpose of this section is really to show how we grappled with the carbon accounting and other impact measurement for these complex products in order for to provide you context for your carbon accounting journey, including how Good may be able to support you on that. So, Joao, if we go to the next slide. Okay, so this is really pardon the pun, Jonathan, but a distilled version of what my team does. Looking first at data collection, we have a technical implementation process with our customers that begins before an initial kickoff and onboarding call and continues through an onboarding period. Takasago was a very unique case for us because of the level of collaboration that we agreed upon to really drive both learning and results at both organizations and really pre-competitively in the industry. The process included ongoing technical check-ins to refine our collective understanding and understand impacts, including as new primary data became available to Jonathan and his team to allow us to make refinements and check them together. For step 2, ingredient mapping, our normal process is really mapping to the extent of our database. For certain customers, like with Takasago, we have to research new, what we call origins or origin locations. So that's the raw primary commodity we're talking about, like a crop or a mineral and such. And then we also had to make new ingredients and to be able to represent those accurately, which we'll get into on the next slide. Step 3, aggregation and heuristics. The aggregation and heuristics can be the aggregation of ingredients into products or applying heuristics to fill data gaps. One step that we often take on behalf of customers who don't know exactly where a crop was grown, we will use global production and trade data to estimate the most likely growing location based on the market where the product is sold and where the product is manufactured. Fortunately, in this case, Takasago had growing locations. We're able to skip that heuristic and work with actual, primary activity data for them, going all the way back to the, country or jurisdiction where the materials were grown. And then fourth, the bottoms-up footprinting. That's really, taking all of our customers' information about their products and translating that into impacts in our platform. And that's similar to what Joao was demonstrating earlier. It's really, I think you saw that demonstration. So for the sake of time, I think we should just move on to the next slide. Okay, so complex mapping, or what does that mean? So we're talking about the carbon accounting and environmental and social impact accounting for complex processes. And at HowGood, we've done this for companies that use precision fermentation to create products such as plant-based proteins, where we have to look at all of the inputs that are going to go into that fermentation tank and the ratios of those to get one equivalent unit of output, like a kilogram or a metric ton of output, and then look at the actual energy and other requirements needed for the processing stage to actually ferment the product. The second category we've worked in is working with suppliers outside of flavors and fragrances that have real custom products. So that might be a real advanced sweetener. It could be a proprietary process for making a semi-finished good that goes into many others. So we've done a lot of that work. We've done actual detailed modeling using primary data. But the real interesting one for us has been flavors and fragrances. So my team has worked on that for years. It was one of the toughest nuts for us to crack because of limited information available to us, because a lot of these processes are or have been in the past treated as proprietary, so there's less information about them that we found in the literature. So that's where we're going to really dig in today for the rest of the time in this section, is really looking at the challenges we faced in doing this work together with Takasago. These are some of the challenges Takasago had, some of the challenges we had in working with their data. So our first phase of work together was to work on naturals as opposed to like artificial fragrances and flavors, because of the challenge opposed to Takasago, and because of how our research really positions us to support this work for Takasago and anyone else in the industry. So the two real big categories of challenges we faced, there were more than this, but we'll just focus on these two bigger challenges. Is allocation of impacts to materials, and then processing impacts. And so like, why were these? Let's just start with allocation and get into this. So I'll explain what allocation is in a moment for anyone unfamiliar with it. First, I'll explain why it's important, especially in this case. So the concentrated nature of materials makes allocation a key step in measuring impacts. If you think of a botanical, or like, Jonathan was talking about mint earlier, or orange oil, like you need a lot of orange peel to get a kilogram of orange oil. Like how many oranges do you need to grow to get enough oil out of all of those peels to get 1 kilogram of orange oil, right? So that's the kind of concentration we're talking about, and how we need to like allocate those impacts appropriately. So to briefly explain allocation procedure in carbon accounting and in life cycle assessment, what we really need to do is look at any of these processes that have multiple outputs, right? So if you've got those multiple outputs and you can't avoid that, you cannot avoid allocation. There's a hierarchy of approaches of how to perform allocation, from ISO 14040, 14044, to get an allocation ratio. An allocation ratio is composed of an allocation factor and then a mass fraction percentage. So mass fraction is really this proportion of mass assigned to each output of a process derived from the primary commodity material. So it's important for calculating allocation ratios, regardless of the allocation method applied. It's even used for economic allocation. So there are multiple types of allocation procedures that can be applied. If you can, you avoid allocation. In this case, with these materials for Takasago, we could not. So economic is a popular choice, economic allocation in the food industry and other industries, but it has limitations. When we perform it, we use notable industry standards like the European Product Environmental Footprint criteria or category rules for certain things, like we have them for dairy and marine fish and other things, but we also have industry standards for commodities that are highly traded and highly visible, like cacao or soy and others where there's good data that we can work with. But those standards even and the PEF rules, the product environmental footprint rules out of the EU, they don't cover all of the materials you can make from those given commodities. So there are limitations there. Allocation can also be performed based on physical relationships, which has its own set of limitations as well if you're going to perform that. Because mass alone, if there's one example of a physical or biophysical relationship, isn't going to represent the importance of that product, that material derived from a commodity in the marketplace and why that commodity was grown and where the impact should really be assigned. And then there's other justifiable methods as well. For a small set of Takasago materials, we applied economic allocation because Takasago provided us with economic data that our team used to perform that calculation and do that modeling. For the remaining materials, we used HowGood's approach we developed, we like to call pseudo-economic allocation. And this approach brings similar logic as economic allocation, but when economic data are unavailable. So, we're working with herbs, flowers, botanicals, and spices that are, when you look at the studies done that provide this data, they're really at the edges of the commodity volumes traded compared to where you find this data. So, there isn't often economic data available for us, at least not widely enough to do this work. So to do this pseudo-economic allocation, we classify materials as co-products, byproducts, and waste, and then look at other output materials from the process to assign an allocation factor in that mass fraction based on that classification, and that allows us to complete the allocation ratio. To do this work, it was important for my team to align with Jonathan's team on definitions for what was a co-product, a byproduct, which we learned, Jonathan, you and your team were calling it side stream, we were calling it byproduct. We just needed to align on that and see, are we exactly aligned on every material? And then, really it was a learning engagement on both sides there, and then define what was really waste. We also had to rethink certain functional units for HowGood. And by functional unit, I mean at that crop level or primary commodity level. A great example is clove. Clove is complicated for this project because of so many parts of the tree used. For example, there's a clove leaf oil extract that can be made. And HowGood had previously focused just on the food side of clove, so the clove bud. And we were treating that as the functional unit, just the clove bud. So we had to rethink that and expand that functional unit to appropriately reflect the impact there of the leaves. And then, we repeated this allocation step and then examining the functional unit for 2 batches of materials and growing location combinations that totaled about 135. So that was a lot of the work that we did around allocation. Processing impact is where it gets interesting. This is another one of the limitations that the team had found prior to this project based on limitations in the little information available to our team on how flavors and fragrance materials were made and processed. So similar to that slide Jonathan showed earlier, where we looked at the different methods like steam distillation or solvent extraction or supercritical fluid extraction, Jonathan and his team were able to identify the processing steps for each of the materials in their portfolio we were working on. Based on that, my team could use that information from the literature to then get the correct information on the energy and therefore the emissions about that to apply or model processing impacts. So like an example on the modeling we had to do is for example of a material that used the CO2 extraction or that supercritical fluid extraction, we found a paper for caffeine extraction using the CO2 extraction. And what was cool about that is it didn't have all the correct numbers we needed in there, but it had a lot of the pieces that we needed. So like Gabby and our team went in there and looked at that and they said, okay, well, we can use these numbers, but we can adjust them based on the production yield from Takasago's material. And if, that was one of the critical pieces of information supplied to us to perform the allocation that we needed, right? Like kind of that concentration of things, like the orange peel example I gave with how many oranges do you need to get 1 kilogram of orange peel oil. So they were able to take that production yield value and replace it and then adjust values there to get the energy requirements by energy type and represent that in our database, which is really cool. So after working through these challenges and performing all the other steps to calculate impacts across life cycle stages, we tested our results and then shared them with Jonathan and his team in a very iterative fashion, that we collaboratively refined some of the calculation inputs or assumptions if there was not complete information based on Takasago's expertise in the industry. And Jonathan, you've worked in the industry so long, you recall a lot of this stuff from the top of your head, which is very useful for us when we have certain questions about, like, well, what about this number that doesn't seem fully complete? And that along with the provision of additional primary data as it became available and further research we conducted really led to the outcomes we saw of this project, which you can see on the following slide, where these efforts resulted in emissions factors on 125 material and growing location combinations for Takasago materials that can be used either as fragrances or as aromas and flavorings. We did a few other materials that are just used as fragrances, but this is really interesting for the overlap with food for HowGood and for HowGood's customers. And what's most unique about the partnership between Takasago and HowGood, it's not just the collaboration required to footprint natural flavor and fragrance ingredients of so much complexity, but the fact that Takasago allowed HowGood to make generic versions of these raw materials available to other companies to use in the HowGood ecosystem. I mean, this means other companies do not need to reinvent the wheel. This kind of pre-competitive collaboration on sustainability data, it enables everyone to make better decisions and invest resources without duplication of efforts. So thank you, Jonathan, and to Takasago for leading the way on that.
And thank you, JD, for that wonderful review of the approach taken. As you've seen, this webinar went kind of deep into the geeky and mysterious pathways of footprinting complex flavor and fragrance ingredients. And we want to make sure that we spend a good chunk of time interacting with you folks that are on the other side, that have questions, that are probably bumping against the same walls and trying to find pathways to collaborate and footprint those ingredients. So with that said, we did receive a couple of questions. I also have a couple of questions to kind of ask from our side. But before I do, maybe I'll start with the first question, and maybe Jonathan, you can start with this one, which is a question that was posted when you were talking about the Scope 1 and Scope 2 component. And someone was asking, how do you measure how much energy and what type of energy is used broken down by process? If you could share a little bit more about how you approach that.
There we are. I'm muted. I thought somebody was going to ask a question. Which year was that photograph taken? It's a little old, I have to admit. But anyway, so in our fragrance and flavor factories, we basically have energy consumption. So I'm talking here about compounding activity. I don't know if the question was more about the compounding activity or if the question is more on the ingredient production. But if we're talking about the compounding activity, we don't have so many processes. We have a mixing blending process, and then we have a spray drying process. So basically we have, in the end, values per kilogram of the total production. So we don't do a specific value of energy consumption per product manufactured. We look at the energy consumption over the year, how many tons of products, and that's what we use. That's the way we split it down. You could always get more sophisticated because one recipe's got 10 ingredients, another recipe's got 100 ingredients. Some need to be heated before they can be incorporated, but we don't go to that level of sophistication as of today.
Excellent. Thank you, Jonathan. And Gabby, is there anything else that you want to add in terms of the how do we approach from an accounting perspective the allocation of those processing?
Yeah, thanks. So I think how we measure is basically taking into account, as Jonathan mentioned, all of the steps needed in the whole change. Sometimes we can do these direct measurements from the equipment itself, but other times we can do or use estimates or models. Two different groups of energy that we can measure is thermal energy and electric energy. Depending on the equipment is the type of energy that we are going to measure.
Awesome. Thank you, Gabby. I'll keep on going with the public Q&A because it's so alive right now. And so there is a question on, is it possible to take us, the audience, step by step through the value chain and decision tree and related data for one product? I don't know, Gabby, do you want to kind of take a stab at this one?
Yep, I can take this one. I can say we can explain a simple example. Let's say orange essential oil, I think is the most simple one. Thinking about the essential oil from orange oil, we need to identify what is the whole change of this production. For example, we need the raw commodity material, that is the oranges from the cultivation stage. So taking into account all the carbon footprint that we have in the agricultural stage to grow these oranges, we need fertilizers, we need fuel. So we account for all of these emissions from the cultivation stage to produce the whole orange, right? So then we need to know what is the process to extract the essential oil. So this process, well, companies like Takasago are able to provide this kind of information, if it's cold pressing or if it's solvent extraction. So we need to know this kind of detail about the processing to identify how much is the energy consumption to do that, what is the allocation, because we know oranges are used for food production, but also for flavor or fragrances, right? So we need to know this kind of decision tree that is based on, well, we have a methodology to identify what is the allocation method, but also companies can provide information about the economic insights about this ingredient, how is the importance of that ingredient in fragrance industry compared to food industry. So we take this kind of decisions to allocate the emissions from the agricultural phase to the specific ingredient for essential oil, right? So after that, we estimate the energy consumption for the processing, for extracting the essential oil. We need to know some characteristics of the essential oil, if it's taken from the peel of the orange or if it's taken from another part of the orange. So this kind of information is also important. Then producing the energy, what are the conditions of the processing, because that is useful on accounting the energy, right? If it's a high process, or if this essential oil is fractionated into a different type of essential oils, some terpenes, some components that are more valuable compared to other essential oils. Then, as Jonathan mentioned, some of the additional ingredients that are needed, the solvent, the emission factor of the solvent, in the case of solvent extraction, of course, transportation of the ingredients, it's also taken into account. Then the processing, emission factors, and then we sum up all these little steps to account for the whole carbon footprint. So we have some of the methodologies that describe all these steps, but of course, we are enriched with information that is provided by the customers.
Awesome. Thank you, Gabby, for holding that long train of thought, an example for one ingredient. Maybe I'll now ask one question to JD, so everybody kind of, is engaged. There's a question on JD, what assumptions were used for the list of the more general emissions factors that we shared in the last slide? If you could talk a little bit about that.
Yeah, we had to hide anything that was proprietary. So anything on the processing side specific to Takasago and their supply chain was more genericized. And anything that was based off of an LCA from a supplier also had to be genericized. So a lot of what we did is very specific to a lot of locations in Takasago's supply chain. So what we could do is show something that's a little bit more general based on assumed locations, say for a continent, or like EU27 is an example for a manufacturing facility, as opposed to somewhere in France.
Yeah, awesome. Thank you, JD. There is another question, and I think maybe I will shift to you, Jonathan, on are there any learnings or recommendations to share with us around the primary data collection process from the farms where those natural ingredients were coming from? For example, did you use HowGood's field scope? Did you send someone to the farm to chat with the farmer? Did you connect with your broker/supplier partner and they took care of it? What was the approach to gather these essential data inputs?
So some of the crops we know kind of very well, intimately, I'd say. So we're well aware of the yields and so on. And then a lot of it we're relying on our suppliers, but also on experts. And to be honest, after a bit of time, you get a feel of where the number should be and does the number sound right or wrong. But I'll be honest, I learned a lot on this process as well, because there are crops which you just don't know so well, and you have to go and search for data and find people to help you on your way. So yeah, it's really, you just have to cross, in my experience, you have to cross a number of inputs and then try to settle on what seems to be the most valid number often.
Thank you, Jonathan. One thing that might be useful for those who've listened to this question and are wondering what is HowGood's field scope, just for you to let you know, like HowGood has a module that enables gathering of farm level data and modeling a specific on-farm emissions factor based on agronomic data. So it's one of the pathways that one can use to gather primary data among many, as Jonathan has mentioned. Then, JD, is there anything else that you want to add in terms of these last question, in terms of learnings or recommendations to share with the audience on primary data collection?
Yeah, I mean, it's a process, right? To get, especially if you're working with a lot of small growers, and that was really outside of the scope of this project. Our initial remit here, as this is going to be ongoing work with Takasago to expand and refine what we're doing together. The first thing was to establish a baseline, which is really what this is that we're showing you here today. And that was important for Jonathan to know, okay, where would we want to consider reaching out to suppliers, and because there is significant resources required to do that, especially with the number of suppliers we're talking about to get to the farm level. So I think it's like, get your baseline, understand that, figure out where to prioritize, and then start making a plan of where to go after it is really the recommendation.
It's just add on that. I know we're coming to the end here, but if I go back probably 3 or 4 years ago, we had 4 numbers for naturals. They were in one of 4 groups, and that was it. That was the level of detail that we had. So now, as we mentioned here, we're up to a couple of hundred where we've got a value for imperfect, but we've got something better, so that we've got a level of sophistication. But it really, every time it's like an onion. Every time you start peeling the onion, another layer emerges. There's another detail which you didn't realize quite how important it was or how significant it was. Then you've got to go off and get extra data to improve the number. So it's a kind of continuous process. we've come a long way, but definitely not at the end of the journey, that's for sure.
Thank you. Thank you, Jonathan and JD. I'll keep us going because we have 4 minutes and a few more questions to cover as much as we can. There's a question on if deforestation is by far the biggest driver of emissions in natural ingredients, isn't there a risk that we are over-engineering the carbon accounting when a bold no deforestation commitment would cut much deeper, much faster? I maybe can kind of start there, kind of just saying that we should never underestimate what we were talking about allocation. So if you think of, you need 800 kilos of jasmine, of starting jasmine flower material to produce 1 kilo of jasmine absolute. And so like, yes, land use change is a critical component for some of the ingredients that come from high land use change origins, which as we've seen are not all. But even for those, kind of the efficiencies on yields and processing kind of have a multiplying effect. And so working on both, like we're going to have to work both hand in hand with both on the processing side and the extraction side to probably achieve significant emissions reductions, especially for ingredients that maybe do not come from high land use change areas. JD, anything you would add on top of that?
Yeah, I think commitments are important, but I think being able to measure the results over time to see if other players involved in the value chain are able to commit to that and you're able to prove that reduction is important. It's important to make commitments. Having been in sustainability space for a decade and a half at this point, I've seen a lot of commitments and I've seen a lot of lack of follow through or problems that have occurred to actually get the results that you're looking for. So I think it's important. We need to do this work to make these commitments. These companies need to, but we also have to follow through, right? It's not like we're just going to make a plan and say, okay, we're done, mission accomplished. We're going to go and say, all right, let's look at the results and let's really dig in and make sure we're getting, it's like trust but verify, right? Like that's that old adage. We need to do that work.
Thank you, JD. Jonathan, do you want to say something?
I'm just reacting to one of the questions there, which made me smile, which is to say, how long would it take you to cover everything? Well, I'll be retired by then, so that's okay. I think the reality is what you do, as you do kind of everywhere, is you start with your higher volume materials, the ones which you think are most impactful. We still have to average for other smaller crops and smaller materials, and you just have to work away at it. It really it's quite a way to go. But
Thank
yeah,
you.
I think we've taken the biggest ones for us. We've tried to capture.
Thank you, Jonathan. Thank you, Gabby, and thank you, JD. We're right on time. If we didn't have time to cover your question, don't despair. We're going to be looking at all of those questions and drafting some responses. So hopefully no question is left unanswered. And of course, all of us are kind of learning together on this. It takes, one of the things that we often say at HowGood is that decarbonization and sustainability is a team sport. I think the partnership that we have with Takasago is kind of a demonstration, an example of that. And we're looking forward to, continue helping move the industry forward. So thank you for joining us today and have a great rest of the week. Bye-bye. See you.
Thank you.